what's well done. Taking you through this story for A-level applied mathematics. And in this video, we are going to go through the marking guide for Senior 5, Math Part 2, Midterm 3 for the year 2024. So this video is suitable for students in both Senior 5 and Senior 6 offering principal mathematics as part of their combination. So these are the papers we hope to upload so far, and the ones we have got so far. And today we are going to go through the marking guide for Senior 5 Mod 3 2024 for GHS, that is Gayaza High School. And if you need to buy some resource books, I encourage you to buy the following. So for principal math, there are 4 books: Math Part 1, Math Part 2, Termly Passwords Marking Guides, and Topical Question Bank. Subsidiary math is only 1 book. Then in physics, there are also 4 books: Physics Part 1, Physics Part 2, Topical Question Bank, and its solutions. So for any of these copies, contact the author on this contact. Okay, so now we shall start with section A, and question 1 says the table below shows that original marks obtained by students in divinity and history examinations. These are the ones. Then part A, calculate the rank correction coefficient and comment on it at 5% level of significance. Then part B, the divinity papers are remarked and one of the students is awarded additional 5 marks. Okay, given that the rank correction coefficient is unchanged, state with a reason the student who received the marks. So we shall come and tabulate. We shall put the marks, the students, then the marks for divinity, let them be X. The marks for history, let them be Y. Then next is to rank in descending order, that is from highest to lowest. So the highest is 93, but there are 2 students with 93. So what we do, we get the would-be average of the would-be position, which is 1.5, and that's what each of them gets. Then next we realize that position 1 and 2 has been taken, so this will take position rank 3. Then this will take rank 4. This will take rank 5. And lastly, this will take rank 6. Then ranking marks for history, highest is 65, rank 1, followed by 60, rank 2, followed by 53, rank 3, followed by 50, rank 4, followed by 46, rank 5, and lastly 40, which is rank 6. Then next you'll get the deviation or the difference, Rx minus Ry. So 5 minus 6 is -1, this minus this is 0.5, this minus this, -1.5, this minus this is 1, this minus this, and this minus this is 0. After that, we shall square these differences. This squared is that, this squared, this squared, this squared, this squared, this squared. Then we add everything to come up with that. So now that we have summation d squared, next is to calculate the rank correction coefficient. So code the formula, substitute n means the number of pairs, which are 6, which will be this. So the final answer should be in decimal places, not in fraction. Then we have to comment. So commenting, we will come and say, so this table is in the logbook, number of pairs are 6, so come here and look for this 5%. 5%, this value is 0.89. Then the calculated value is 0.8429. That means that because the calculated value is smaller than this, the comment will be insignificant. And that's what they wanted. Then part B, it says the divinity papers are remarked and one of the students is awarded additional 5 marks. Given that the rank correction coefficient is unchanged, state with a reason the student who received the mark. So for the rank correction coefficient not to change, it means that the ranking must remain the same. Therefore, when you add an additional 5 marks, the student must stay in the rank where he or she was. So here when we add 5, we shall get 80. We shall get 80 and realize that there is 79 here, meaning that this student will change the rank. So we leave that. Then when we come to 93, when we add, we shall get 98. But the funny thing is that this one will change. This and this will no longer be identical. So that is not okay. So these are not okay. For this one, when we add, we shall get 76. But here there is already 75. So that is not okay. Here when we add, we shall get 88. And the good thing from 88, there is no, I will not have bypassed any other. So that means that student T is the one who was awarded the 5 marks. So I'll come and say that students T received the 5 marks, and the reason is that when you add, you get 88, which is still smaller than 93, making the students' ranks remain the same, and hence the rank correction coefficient remains unchanged. That was question 1. Now question 2. Question 2 says a particle. So question 1 was from statistics, and that is Spearman's rank correction coefficient. Question 2 is from mechanics. It says a particle is projected with a velocity of 49i. That is now vertical motion. Calculate the time interval within which the particle is at least 78.4 meters above the ground. So considering vertical motion, we know that S should be greater, because they use the word calculate the interval at least. At least means that or more. That's why you say S is greater than or equal to 78.4. Then this is given by this formula. So you can now substitute. So U is this because J means that it is purely vertical. There is no horizontal component. That's why there is U, we put 49. G is 9.8. And this is known. So I have only one unknown, which is T, meaning that I can solve that. So that will be a quadratic inequality. Simplify by dividing through by 4.9 to give you that. Then factorize to get that. So the critical values are those ones. Then we shall come and draw a table of signs. So for values before 2, it will be given by t less than 2. Then values between 2 and 8. Okay, for values, let's begin with values before 2. When you put maybe negative, okay, let's put 0. 0 here to be negative, and here to be negative, so the product should be positive. Then between 2 and 8, let's choose 5. When you put 5 here, you'll get a positive. 5 here, you get a negative. So product will be negative. Then values after 8, let us say 10. When you put 10 here to be positive, 10 here to be positive, so product will be positive. So this inequality says less or equal to, meaning they should be negatives, which is this. So you come and conclude that the required time interval is from 2 to 8, and that's what they wanted. Then question 3 says it's now under numerical methods. A car consumed fuel amounting to shillings this, and this, and this, in covering distances this, and that, respectively. Estimate the cost of fuel consumed for a distance of 45 kilometers. And part B, the distance traveled if fuel of shillings this is consumed. So you realize that 45 is outside here, so it will be extrapolation, and 16,000 shillings is between this and this, so it will be interpolation. So you come and tabulate the necessary values: 30, 40, and the 45 which they want. Then we shall use linear extrapolation, where we shall say this minus this over this minus this is equal to this minus this over this minus that, to give you this step. Then we simplify, make y the subject, and that will be the answer they wanted. Then for part B, still we extract out the necessary values. It was interpolation. Then we equate quotients: this minus this over this minus this is equal to this minus this over this minus that, which is this step. Then we simplify and make x to the subject, and that's what they wanted. Then question 4 is from probability. It says a coin is biased such that when it is tossed, the head is twice as likely to occur as the tail. Find the probability that in 7 tosses, so that makes it a binomial distribution, there will be exactly 2 tails. So they said a head is twice as likely to occur as a tail. So probability of tail to probability of head is 1 to 2. Meaning that probability of tail is 1 over the total ratio, which is 3. Probability of head is 2 over the total ratio, which is 3. So this is a binomial with 7 trials and probability of success 1 over 3. Reason because they ask for exactly 2 tails, so probability of tail is the probability of success. Exactly 2 means x equal to 2, so we'll come and quote the formula. So I'm using the formula because this value is not there in the logbook. Otherwise you would have read it off, and that's what they wanted. Then question 5 says a particle of mass 5 kilograms is acted upon by forces, these ones, acting in directions, these ones, okay, respectively. Find the acceleration of this particle. So one we need to resolve. So this one corresponds to 30, giving us this. This one corresponds to 135, this one corresponds to 250, and this one corresponds to 290. Then you can use a calculator to come up with that output. So the wanted acceleration, so you shall say second equation, Newton's second law, gives you F equal to ma, where F is the resultant force. And a good thing, the mass was given as 5. And this is the resultant to come up with this. So you should realize that we're leaving an answer in vector form because acceleration is a vector quantity. So question 6 says, given that, so question 6 is under numerical methods, the topic of errors. Given that m is this, n is this, rounded off to the given number of decimal places, determine the interval within which the exact value of this lies correct to 4 decimal places. So you come and get the minimum. So to minimize this, to minimize a subtraction, it means that this is smaller and this is big. That's why you see this is smaller. Then to make this one maximum, it means up it should be maximum, down it should be minimum. So use a calculator, come up with that. To maximize is the reverse. This should be big, this small, and this big, to make it that. Then you write, because they wanted interval, so you can write box bracket, and that's what they wanted. Question 7 says a particle P of mass 2 kilograms is attached to one end of a light inextensible string and the other end of a string attached to a fixed point O. Okay. The particle is held in equilibrium with OP at 30 degrees to the downward vertical. Know that word, downward vertical, by a force of magnitude F. The force acts in the same vertical plane as the string and acts at an angle of 30 degrees to the horizontal. Find the value of F and the tension in the string. So in one, we need to make a sketch. So the string makes an angle of 30 degrees to the downward vertical, which is this. Then the particle has weight, and because the string is tight, there will be tension where arrows point towards each other. So to complete this, it will be a right angle triangle, meaning that this, if this is 30, this will be 90, and this will automatically be 60. Then the force acts at an angle of 30 degrees to the horizontal. They are in equilibrium, so you can now resolve horizontally, where we say forces to the right are equal to forces to the left. So T cos 30 is equal to F cos 30. You substitute for this and for this to come up with equation 1. The next is to resolve vertically. Vertically, we shall say T sin 60 plus F sin 30 is equal to 2G. Substitute for this, substitute for T from equation 1, substitute for sin 60, which is that, and sin 30, which is that. And also substitute for G, which is 9.8. Now here we have only one unknown, which is F. So simplify to get the value of F. Then from equation 1, you can get the value of T. And that's what they wanted. Question 8 says, a discrete random variable x has the following probability distribution. Okay. Find Roman 1, the value of P, and Roman 2, the expected value of x. So summation of total probability should always be equal to 1. So come and add all these probabilities and equate to 1. So P is the only unknown, meaning you can get the value of P. Then question 2, they wanted, part B, they wanted the expectation. Expectation is x times the rate of x, summation of the x times the rate of x. So you keep multiplying x with this probability, x with this probability, x with this probability, x with probability, x with probability, x with probability. Then use a calculator to come up with the required expectation, and that's what they wanted. That was section A. Now we shall go to section B. Section B had 3 parts. There was a part of statistics and probability, a part of mechanics, and a part of numerical methods. So in each part, a student was supposed to select only one question, and each part had 2 questions, I think. So question 9, part A says, if events A and B are independent, okay, show that events A prime and B prime are also independent. So let's begin with that. So when we know that this A complement intersection B complement is the same as A union B when the complement is outside. So when you pull this complement outside, even this sign changes to that. And this is the same as 1 minus probability of A union B. Then you can expand this to give you this. But remember the brackets. You have to use the brackets. Okay. We already know that these 2 are independent. So A intersection B is the same as A probability of A times probability of B. Then you realize that, okay, when I open brackets, I come up with that. Then I can combine this. Okay, I can combine these 2 and this and factorize. So for this one, I'll come up with this bracket, then minus this. I'll come up, put B probability of B outside, you'll come up with 1 here and minus probability of A there. So this can be complement. So this will be A complement, this will also be A complement. Now A complement is also common, so pull it out, you should come up with this. And this can also be B complement. Now because this is equal to this, then the events A complement and B complement are also independent. And that's what they wanted. Then part B says, in a certain school, a student may travel to school by car, bicycle, or on foot. Okay. The probabilities of using a car, bicycle, or foot are these, respectively. When a student used a car, the probability of arriving in time was this, and by bicycle is this, and by foot is this. Okay. Then here they said, find the probability that a student selected at random did not arrive on time, and 2, went on foot if. Do you see this word if? It means it's a conditional probability. If he did not arrive in time. So here it's better we use, if there are conditions, it's better we use tree diagram. So it's probability of using a car, bicycle, foot, and arriving on time, not on time, time, not on time, time, not on time. So we can put what is given. We have that, that, and that. Then on time that. So complement, because each branch should add up to 1. So 1 minus this gives you a quarter. Then for this 1 minus this gives you 3/5. Then for this 1 minus this gives you 9/10. Now Roman 1, arriving on time, we have this, this, and this. So for this it is here, for this it is here, for this it is here. Then we substitute this times this, this times this, and this times this. Use a calculator to come up with this probability which they want. Then Roman 2, foot given, not on time. Expand numerator is intersection, denominator is what comes out of the slash. Intersection f, we already got it. Okay, it isn't there. So there is this and this, so multiply these two. Denominator t complement is 1 minus this to give you this as the answer. And that's what they wanted. Then question 10, the time t in seconds taken by a group of 52 pupils to perform a task is summarized as follows. Calculate the mean time, standard deviation, and then draw a histogram and use it to estimate the model time. So here we shall need to tabulate the time. We shall come and put the time. Then the frequency, and this is the total of all these ones. It gives you this. Then they asked for mean, so we need to get fx. So x is the midpoint, this plus this over 2, 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 and this plus this over 2. Then from there you shall get multiply fx, so this times this, 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 and this times this. Then add all these ones to come up with this summation. This was for standard deviation, so we need fx squared. So this times this squared, 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 and this times this squared. Add everything, you come up with this. Then class width, because they ask for histogram, we need to identify whether the class widths are equal or unequal. So this minus this, 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 this minus this. So class widths are unequal, meaning that we shall use frequency density. So we have to get the column of frequency density, this over this, 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 and this over this. Okay, so now we are good to go. Roman 1, they wanted a mean is this divided by this to give you this as the mean. Then they also wanted standard deviation, quote the formula, substitute, and get the output. Then next was the histogram, so we shall need the graph paper. Draw the axes, horizontal and vertical. Then use intervals of 2 centimeters and get a good scale. And label. Same applies to the vertical axis to 2 centimeters. Then you get a good scale and label the axis. Then you shall start plotting. Histogram will use bars. So first frequency is that, next frequency density is that, next, next, next. So we are plotting frequency density against class boundaries. And lastly that. Then they ask for the mode, so we shall need to join this point to this point and this to this point, get the intersection and drop it down to read off the value on the horizontal axis using dotted lines. So drop perpendicular to meet the horizontal axis and read off that value, and that will be the answer. and that's what they wanted. So that was part B1. Now we shall go to part B2, which is numerical methods. So question 11 says, part A, use the trapezium rule with 5 sub-intervals to find the approximate value of this, correct to 3 decimal places. So let's begin with that. So first we'll need to get the strip width, then we can tabulate. Ordinates are those ones. Then xn, lower limit is this, keep on adding plus 0.1, plus 0.1, plus 0.1, plus 0.1, plus 0.1 until you reach the upper limit. Then for these values, substitute them in the given expression for this and for this. Then intermediate, this one, this, when substitute, then you can add. After that, you code the formula. So this is the expression where we substitute our values of x to get the corresponding values of y. Code the formula and substitute strip width, sum of extreme values. So extreme values are here, sum of intermediate values are here. Going to get the output to the required accuracy. That was Roman part A. Now part B says, part B Roman 1, find the exact value of this, correct to 3 decimal places. And Roman 2, determine the maximum relative error in your estimation in A above, correct to 3 decimal places. Okay. So exact values, we use integration techniques. Integrate this gives you this, integrate this gives you this. Then substitute limits, upper limit here and here to give you this, lower limit here and here gives you 0. So they are giving you this as the answer to the given accuracy. Then relative error is, first is absolute error over, in this case it is absolute over exact value. Absolute means exact minus approximate over exact. Exact is what is got by integration techniques. You'll come up with this as the answer to the required accuracy. Then question 12 part A says, on the same axis draw the curve this and this to show that the function this has a root in the interval 1, 0 to 1. Hence estimate to 2 decimal places. Estimate the root. So let's begin with that. So we shall need to tabulate because we have to draw a graph. X. So for x equal to 0, this is that and this is that. Then for x equal to 0.2, this gives this. When x is 0.4, we get that. When x is 0.6, when x is 0.8, and lastly when x is 1, this gives you this, and this gives you this. I think you realize that these values are not filled because for a straight line we only need 2 points. Once we get 2 points, we just join using a ruler. Then we shall need a graph paper and draw axes and label them, x-axis, y-axis. Then get a correct scale. For the x-axis, do the same for the y-axis. Then you plot, let's start with this. So 0 corresponds with 1. So you put it here. 0.2 corresponds with 1.22. 0.4 corresponds with 1.49. 0.6 corresponds with 1 2.82. 0.8 corresponds to 2.23, and 1 corresponds with 2.72. So we need to join using freehand, and the curve should be reasonably smooth and labeled. Then for this line, this 0 corresponds to 3 and 1 corresponds to 2. Then we join, by this time using a ruler, and we label. Then they intersect a starting point. That is where the root we need. Now next we need to conclude that since the curve and the line intersect between this and this, it implies there is a root between this and that, and you've got the root. So that's what they wanted in part A. Then for part B, they said locate the interval for each of the roots of the equation this for the range this. So range of magnitude of x less or equal to 4 means from -4 to 4 inclusive. So you're coming and tabulate. Fx is that. So -4, fx is that. When x is -3, fx is that. When x is -2, fx is that. When x is -1, fx is that. When x is 0, fx is that. When x is 1, fx is that. When x is 2, fx is that. When x is 3, fx is that. And when x is 4, fx is that. Then we need to look for a change of sign. So here there was a change of sign from negative to positive. Here a change of sign from positive to negative. And here a change of sign from negative to positive. So those are the three roots. Therefore we shall come and conclude, since f1 and multiplied by f0 is less than 0, there is a root. Also this, there is a root. Also this is less than 0, so there is a root. And that's what they wanted. That was part B2. Then part B3 is under mechanics. Question 13 says, a motorist starting a car from rest accelerates uniformly to a speed of v meters per second in 9 seconds. He maintains this speed for another 50 seconds and then applies brakes and decelerates uniformly to rest. Okay. His deceleration is numerically equal to 3 times his previous acceleration. Okay, part A. Sketch a velocity time graph for this motion. And part B. Calculate the time during which deceleration takes place. Part C. Given that the total distance moved is 840 meters, calculate the value of v. And part D. Calculate the initial acceleration. So shall need to sketch a velocity time graph. So draw the axes and label them. So remember, this is a sketch. So for the first 9 seconds, it means this is 9. And velocity is v because it's not known. So we shall come and draw an acceleration. For the next 50 seconds, this becomes 59. And the velocity is constant. For the next unknown time, let this one be capital T, and there is deceleration. And acceleration is 3 times this. Deceleration is 3 times that. So that was part A. Then part B, we shall come and say that for acceleration, using first equation of motion, we shall come and substitute v is unknown, but u is known, it's 0, a is unknown, and t is known as 9. So we can come and get equation 1. For deceleration, which is here, still first equation of motion, v is unknown, sorry, v is 0 and u is v. So come and substitute 0, v, and a, which is this. to come up with that. So here what I've done is substituted for V, which is here. So in the end I'll come up with that, and mean that this can cancel. You remain with 9/3, which gives you 3 seconds. And that was part B. Then for C, part B, it said, because they asked for calculate the time during the acceleration, which is that. Then part C, given that the total distance moved is this, calculate the value of V. Then part D, calculate the initial acceleration. Okay, so value of V, we shall need to get area of a trapezium. So we need to get this value of capital T, then you can use area of a trapezium. So capital T is given by that, therefore area of a trapezium is equal to the total distance. Substitute distance V T2 capital T. There's only one unknown, so we can get the value of V. Then part D, from equation 1, we can come up with that, mean that A1 is that. And that's what they wanted. Then question 14. One end of a light inextensible string is attached to a block A of mass 5 kilograms. The block A is held at rest on a smooth plane inclined at alpha degrees to the horizontal, where sine alpha is that. The string is parallel to the line of greatest slope of the plane and passes over the smooth light pulley, which is fixed at the top of the plane. The other end of the string is attached to a light scale pan, which carries two blocks B and C, with block B on top of block C as shown in the diagram. So let's see the diagram. Okay, if the mass of B is 5 kilograms, mass of C is 10 kilograms, and the system is released from rest, find Roman 1 the acceleration of the system and the tension in the string. Then 2, the magnitude of the force exerted on block B by block C. Then part C, the magnitude of the force exerted on the pulley by the string. Okay, so here we shall need to redraw and show the forces acting. So now for show the forces, here there is weight acting vertically downwards, resolved into two components, part of the plane and perpendicular to the plane. Then there will be normal reaction and tension in the string, arrows pointing towards each other. Tension here, arrows pointing towards each other, and total weight, which is 15 grams. Then the motion shown by acceleration here, and also here shown by this acceleration. Then for mass A, we can now use equations of motion, Newton's laws of motion. For mass A, we are interested in this. So T minus this is equal to 5A. Substitute for G and come up with equation 1. For mass B and C, 15G minus T is equal to 15A. Substitute for G and come up with the second equation. So there are two equations and two unknowns, meaning they can be solved simultaneously. So when I add the two equations, I'll eliminate T and remain with A, which can be got. So you can remove these ones. Then from equation 2, I can substitute for A and get the value of T. Then part B, reaction of C on B is the same as its weight, which is that. then part C, reaction at the pulley, fixed pulley. It will be 2t cos half the angle. Let's go back to the diagram and understand it. So here, because these forces are the same, it implies that the reaction is along the line of symmetry. Along the line of symmetry here. Okay, so that means that this angle will be divided into 2. Therefore, the resultant reaction here is equal to the resultant tension here, which is 2t cos half this angle. So that's why you saw us write 2t cos half the angle, and which gives the answer they wanted.